In this tutorial, we're going to integrate the concept of collision detection in our GameObject class. And the way that we're going to do it is going to be slightly different than what you may have seen in the other video tutorials. In those tutorials, you were doing more of a rectangular hitbox approach, and in this case, we're going to use more of a circular approach. Now, you may be asking why we're doing something like that. If I were to open up some of our assets, such as smoke.png, you can see that the area of collision is mostly circular, and even our zombie class here has a mostly circular shape to it. So in this case, it's a little bit more appropriate to do it that way. So to get this concept going, what we'll do is to declare an int, and we're going to call this thing hit size squared. Now, one thing that we're trying to avoid is to calculate a raw distance that uses that square root function, because the square root function is a very expensive function to calculate. So what we'll do is we'll leave everything kind of unresolved in this squared format. Okay, so to initialize that hit size squared, we're going to base it off of the texture size. So what I'll say is this dot hit size squared gets text dot width times text dot width. Now, you may be wondering why we use width as opposed to height. Here, again, we're assuming that the shape is mostly circular, so it doesn't really matter. Okay, so let's go ahead and stub in the method, and this is going to be called public virtual bool, and we'll call it collides with. Okay, now the key here is that it's going to take in another game object, and we'll call this guy other. Okay, so to be able to calculate the distance, we'll actually use the distance squared, and again, that's an optimized kind of method. So we'll say float distance squared gets, and then we're going to use the vector3 method distance squared. Now, notice that this takes two different references to vector3s, and so the two that I'm going to pass are other.pos, in other words, the thing that's coming in as a parameter, and this.pos. Okay, so at this point we now have the square distance between this object and another object that's in the game. So the logic behind this is relatively straightforward. We can say if the distance squared is less than the hit size squared, then we know that we have a collision, so we will return true. Otherwise, flat out, we're going to return false. Okay, now the nice thing about putting collides with in the GameObject class is that now particles know when they collide with other things, zombies know that they collide with other things, and the player does as well. Basically, anything that inherits from GameObject gets this for free. So now what we can do is jump over to app main, and we can start to do some interesting things here too. So what I'll do inside of update is for every zombie that's here in the zombie list, we're still going to tell it to update, but let's go ahead and do some collision detection with the particles. And if a zombie ever touches a particle, what we'll do is we'll mark both of those things as being dead. So watch this. I'll say for each particle P in heroes party list, then what we'll do is to say if P dot collides with Z, then we'll both mark P dot is alive as false, and also Z dot is alive as false. So if you look at the structure of what's going on here, we're saying that for every zombie that's in the zombie list, compare it with every particle that's in the party list, and if we have a collision, then what we'll do is we'll mark each of those as being dead. Okay? So the last thing that we have to do is to clean up any dead zombies that might be here. In fact, I'll just put a little comment here, clean up dead zombies. And again, remember that the particles are cleaned up inside the player class, so we don't have to do that twice. But we'll go in reverse order just like we did last time. For I gets zombies.count -1. Okay, so long as I is greater than or equal to 0, I minus minus. That looks good so far. And then we'll pull a zombie out of the list. So we'll say zombie temp zombie gets zombies of I. And again, we're accessing the list the same way that we would access an array. And then if the temp zombie, or I should say if not temp zombie is alive, then we know that we need to remove that zombie from the list. So I'll say zombies.remove and pass it temp zombie, because I know that that zombie is dead. Now, it's interesting because when I run this, you'll see that we still have zombies on the screen, and as I shoot, you can see that we kill them. It doesn't take a lot of flames for them to die, but it is fairly accurate. So I'll come over here and I'll say bring it. Okay, so nothing is a problem anymore. Okay, so there we go. We now have collision detection, but it's important to understand where we put it. We purposely stuck it here inside the GameObject class because now any GameObject can see if it collides with any other.